fundamental truth to our nature. Man must explore. And this is exploration at its greatest.
Data is the new oil pushing the world around.
Each person creates enormous amounts of data every day. We create the data that we want to create. Other data is like metadata that's not created intentionally.
It's hard to predict how many data is stored around the world.
With digitalization, the problem is that data is reachable by anybody.
These characteristics make it easier to modify.
So it's the complexity which is the problem, not the volume of data that we have.
The data brings power and the money.
Nothing in this world is 100% safe.
If security was a simple problem to solve, it would be solved decades ago.
Nobody thought about security.
We are dealing with malicious human attackers trying to cause some damage.
One laptop is compromised, then the whole network can be also compromised.
It is obvious that the numbers we are seeing are proving that cybercrime works.
Usually the motivation for the attackers is money.
Ransomware is not, I think, a technical threat, it's a business model, which was not really the case in the previous decades.
This is, let's say, the plague of today's cyber world.
It spread around the network and encrypted the files on laptops, computers, servers.
Companies which have, let's say, less than 500 employees are still seeing damages around 2 million euros per incident.
The problem is that awareness at the top management is not big enough.
We're talking here about organized crime.
We are like surveillance cameras, we are the alarms, and we are the security personnel. Now imagine bank robbery without these three things.
Security is a very complex project. You need a lot of experts.
An attacker needs to find only one problem in your defenses, but you need to defend all the possible problems that you might have.
Only humans can understand human behavior.
I think it's always better if you do it yourself.
Can they do it? It's another question. I think very hard.
It's a game that is constantly played by adversary and defender.
You need to detect all the things that are flying under the radar of the prevention.
You have to be certain, right? Because we're talking about cybercrime here.
The top dogs in a company, if things are explained to them properly, they would actually understand how this works.
Humans are the weakest link in cybersecurity chain.
Okay, so I guess it's time for us to start. Welcome everyone. And I was actually expecting another video, but I think this is about it. So welcome to the discussion about Zero Trust architecture and how we establish this with VMware solutions. My name is Stojan. I'm coming from Nil. So I've been with Nil since 2004, achieved some certifications, have been working with a bunch of different vendors, obviously with the VMware, Cisco, RSA, Microsoft, IBM, and others. I'm also quite engaged in open source solutions. I'm currently working as an architect, as a security mentor, and so forth, and wearing different hats at different times, so be it an engineer, instructor, or an IT architect. As I mentioned, I'm coming from Nil. So we're an advanced IT solutions company, providing services, consulting, and training across the world. with offices in Slovenia, Canada, Morocco, Serbia, South Africa, UAE, USA, and so forth. As far as VMware goes, we've been working with VMware since 2003, when we set up our first remote labs on the VMware platform. Currently, we hold 22 VMware certifications, including 2 of the most advanced VMware professional certs that are out there. And we have recently received the VMware Principal Partner certification for networking security, proving our investment, proving our expertise and knowledge about the whole portfolio. So Nil has been a partner of Conscia Group since last year. It's an international group based in Europe, and we've been thriving in that role as well. So basically looking forward to good times. So what will we be talking about today? We'll talk about what Zero Trust is, what it isn't, how it is implemented in your environment. We'll talk about how VMware implements the architecture, how we secure our workplace, how we secure our data center, how we secure our remote workers and remote locations. And then at the end, we'll talk a little bit about how we actually enable the solution in your environment and how to actually make it work with VMware solutions. If you have any questions, I will be reviewing those at the end of the session, or I will also be posting in email where you can drop me questions if you have any to ask. Okay, so let's start off with Zero Trust, what it is, what it isn't, and so forth. So Zero Trust by default doesn't mean I don't trust anything, I don't trust anyone. What it does mean is that I don't trust you unless I know you. It means that unless I know your context, unless I know your identity, unless I know what you're all about, I will not trust your connection, I will not trust your data, I will not trust your compute, but basically trust needs to be earned. So I need to understand your context, I need to see your identity, and basically what that also means is that there are no longer any internal networks that are by default trusted. There are no users that are trusted by themselves, but we allow people, applications, and workloads just enough privileges so they can perform their tasks, be it an application that needs to reach to a database, be it a person that needs to connect to a web service, be it some workload that needs to run on a specific data center. We assign the least privilege that is actually required by the application, by the user, by the flow, depending on the context. So what is critical when deploying Zero Trust solutions is understanding the identity and context which surround the action that is actually taking place, setting up logical access boundaries. So physical connectivity is basically ubiquitous. So we normally use Wi-Fi, we use WAN links, we use local networks. So physical doesn't really translate to what security is anymore, but it's really about logical boundaries, about contextual boundaries, again, fully understanding what it is that we're trying to perform, and basically authorize the access on the fly. So access is restricted and authorized by a trust broker, which will understand the context. It will understand who the user is, how they're connecting, where they're connecting to, what the application that they're connecting to is doing, etc. And as this is established, the connection is set up, and the context of this establishment is continuously monitored. So it's not set once and forget, but we continually verify the context of the connection, the context of the workload execution, the context of application functionality, and so forth. So there are no applications, there are no apps, there are no DBs that are, let's say, open by default. Again, just because you're my local network, just because you're my boss, or just because you're an IT user doesn't mean that you have access to everything. No, basically you need to be authorized. I need to understand your context, and your access will then be granted. Within VMware world, we normally operate on basis of user identities, devices, networks, and then obviously workloads and postures. Meaning that I do need to understand who the user is, who the application is, who on which level of connectivity I'm currently operating, which device is trying to connect to my workloads, across which path, using which network, which type of access, and then obviously what is it trying to access. So which application, at which layer, again, what are the contextual information that I'm trying to achieve, and so forth. In order for us to do this, we need to set up the context of the connection in order for us to actually establish it. We need to establish user identity using either passwordless, multi-auth, behavior-based identity of the user of the app that's actually connecting, and obviously include the conditional access variables such as the posture of the endpoint. Is it compromised? Is it running the acquired apps? Is it a corporate assigned device, and so forth? We need to understand the device posture. So is it managed? Is it in our inventory? Is it compliant? What are my threat detection components telling me about this app? We need to provide adequate network segmentation, which again, fully understands the context. It's not a static segmentation. We don't no longer just have one big data center, one big core, one big LAN. No, basically we are talking about micro-segmentation, which is achieved by using intrinsic security built into tools such as NSXT and so forth, and thus allowing session protection, secure access, full encryption across the full path, and so forth. And why is this all important? Well, obviously to secure our data, to secure our workloads, to secure our applications, where again, by using the context that we achieved previously, be it by identity, posture, network access, we use that context as a single sign-on so that users need to identify, but they need to do it once. We don't want to burden them with having to re-authenticate every couple of minutes. We achieve application integrity. We can run vulnerability scans, achieve virtual patching, and so forth. So again, integrated security within our workloads, within our applications, providing the topmost security possible that is out there. And by doing so, we achieve full visibility. We can pull out analytics. We can leverage automation and orchestration to actually achieve the tasks. So it's not feasible that we would expect one person or one IT department to actually cover this 24/7 to monitor it, to control it, but we will rely on automation and orchestration to actually provide this for us, provide reporting, provide analytics, and give us the data that we need. So which are the trends that are currently driving Zero Trust? Obviously, there's the digital business transformation. So everything is moving somewhere. Is it going to the cloud? Is it going to the data center? Is it going across the globe? So as the users, as the workloads, as the data is being pushed all around the world, again, setting up boundaries is quite hard. And again, we need to fully understand the context of the connectivity. We need to understand where, when, how, who, in order for us to actually achieve that. The users, again, are using multiple devices, connecting from multiple locations. We're all working from home. We're all working from remote offices, etc. So again, how do we achieve integrity? How do we achieve security using those environments? And obviously, our apps are running on different platforms without any enterprise boundary and in changing partnerships. So depending on who we're currently working with, again, we need to fully understand the context of the connection in order for this to actually work. And as I mentioned, during the COVID times, during the situation that we are currently in, with everyone working from home, with applications running in the cloud, working in the enterprise, working with different SaaS providers, IaaS providers, and so on. Again, how do we actually achieve security? What are some tools? What are some methods in order for us to fully understand the context, provide secure connectivity, and allow maximum productivity using those tools that we're currently using? So let's first focus on the architecture and how this all actually comes into play. As we said, the business, as we know, is getting reshaped. So our workloads, our users, our servers, our locations are all around the world, all around the continent, all around the cloud and so forth. And actually achieving some security is very, very hard because as Jan was just saying in the video before, the attacker just needs to succeed once. So they need to basically guess an admin's password. They need to, let's say, break into a SaaS environment. They need to compromise a microservice. They need to, let's say, break into a database and so forth to steal our data, to exfiltrate information and so forth. And monitoring all that, securing the whole environment is becoming increasingly hard. So how do we actually secure this? How do we make things more secure but still usable? Because if the users cannot use it, if the applications cannot run, if we don't have access to what we need, well, then this is not what we want to achieve. So how do we trust the workloads, the applications, the data? Where do I apply our granular filtering and so forth? Well, when dealing with VMware, when talking about the tools that are actually available to us, we can verify our workloads. So to make sure that our users, our endpoints are actually secure, we can provide dynamic contextual segmentation with intrinsic security. We provide data encryption. We make sure that users and applications are identified, make sure that we understand the device posture, use secure access and so forth. And how do we do this? We're using tools like Workplace ONE with Carbon Black. We use NSXT firewall within the data centers. We use data encryption with vSAN to provide security of our data. Again, make sure the devices are compliant using the Carbon Black and Workspace PAN, and provide secure connectivity using SD-WAN and SASE for connection of all the endpoints together. So let's first talk about the workplace. And just before we go that, so for those of you who are working on the Risk game, this is the keyword that you might be using. So we're talking about the workplace security. The tools of the trade here are Workplace ONE and Carbon Black. So Workplace ONE is the centralized management monitoring tool that our IT department is using to provide end user services, to provision the devices, to provision the apps, to set up secure connectivity and so forth, while the InfoSec team would be using Carbon Black to provide security of the endpoint devices, to prevent any malware, ransomware, and so forth attacks, to provide baseline visibility into the whole solution and so forth. So how can we achieve that? So what are some basic use cases where we can leverage zero trust control? So with device health, using Workspace ONE, we can modernize PC and other device management from Android to iPads to iPhones and so forth to have a simple baseline with the applications that the users need, and obviously to understand any threats that those devices are exposed to, and to reduce the alert fatigue. So only be alerted when alerts need to be triggered. With zero trust access control, again, fully understanding the context, we utilize SSO to provide the best use case visibility. We minimize the attack surface, and we augment the threat data for risk analytics. And again, focus on the things that are actually important and discard what is not. And then again, implement threat response and orchestration. So again, try to make our lives as IT admins, as IT leaders and so on easier by providing unified dashboards, by providing orchestration. So let the machines do the work for us. We don't need to do everything ourselves. Provide device quarantine and provide speedy responses and quarantine times for the devices that we deem vulnerable, that we deem compromised, and so forth. Again, as we share the context of those devices, we can automatically ingest the device threat data, fully understand the threat level on the devices that we're using Carbon Black sensors, provide this data on unified dashboards, look at this across the whole platform, and basically enforce the desired state of our devices. So as soon as we see a deviation from our baselines, we know that there's something going on. We can utilize our built-in tools to provide zero trust access control for any applications that our users are using. Again, users need to be on a trusted device. We need to know who they are. We need to know that they're coming over secure connection. Well, if that's all true, sure, you can access our data center. You can use our software as a service applications, but we need to know who you are. We need to know that you're secure, that the connectivity is encrypted for this to actually work. We provide agentless hypervisor security, about which we'll talk about in a bit, prevent malware, ransomware, and so forth, and integrate this with secure connectivity using the Secure Access Service Edge platform provided by VMware as well. And again, to make our lives easier, we can provide automation and orchestration in case we see deviations from the baseline. Again, by using the intrinsic security within the tools, within the Workspace ONE intelligence and automation that we have available, we can actually trigger actions such as quarantining users, revoking certificates, disconnecting the VPNs, etc., based on the automated responses that we set up in advance. So again, by understanding the context, understanding what is actually happening, we can leverage this information and trigger changes within either VMware infrastructure or third-party tools such as ServiceNow, Slack, and so forth. Okay, the second part that's obviously important is the data center. So we know our users, we know the endpoints, we know the devices they're using to connect. We're using Workspace ONE to actually manage them, to control the applications, the users, the connectivity, and so forth. But then our data needs to reside somewhere. Our applications need to be up and running. So when talking about data centers, again, do we just have one big data center where all the machines, hardware, VMs, etc., are talking to one another, that we basically extend our compute into AWS and Azure and so forth, and basically everyone talking to one another, and set up one big castle, one big wall all around the whole environment? Well, unfortunately, that doesn't work anymore, because we need to understand, again, the context of those connections. We need to understand why this VM is talking to that user, or why this DB is talking to that front end, and so forth. And in order for us to actually achieve a zero trust based security, we need to be a bit more granular. We actually need to understand the security required for an application to work. We need to understand, okay, which connections are actually required between the front end, DB, back end application, and so forth. We need to understand which are our secure zones, such as a PCI zone or a secure data zone, and so on, and who is allowed to actually access those. And we need to basically be able to do this in a dynamic way, using the context, using the information that we get from the tools that are available to us. So using microsegmentation, which we can achieve exactly that. And the NSXT distributed firewall allows us to do this over VMs, over containers, bare metal servers, native cloud applications, VMware cloud applications. So wherever our workloads are currently running, be it in our cloud, be it on the public clouds, be it basically spread all across the world, we can attach the policies, we can attach the rules, we can attach the appropriate ways on how those workloads can communicate to one another directly to those workloads. And this is the critical part. So the policy is attached to the workload. If the workload moves, the policy goes with it. And it doesn't matter on where the user is, where the app is, where the connection is set up. If we understand the policy that is required to access this device, for this device to communicate outwards, this is all that we need. And by leveraging, again, full contextual information, so understanding the network characteristics, understanding the ports, the protocols, understanding the identity, understanding the security functions of certain VMs, of workloads, etc., that we are running inside our environment, we can apply appropriate tags. And then based on those tags, NSXT distributed firewall will provide distributed filtering and will provide full zero trust based security within our data centers, be it on the internet facing, be it internal, be it on a public cloud, private environment, and so forth. So obviously, NSXT by itself, okay, it's a great distributed firewall. You can do a whole lot of stuff, but it's really good to understand what's actually running under the hood. And what is actually built into the latest releases of the tool are some very powerful microsegmentation tools that are currently available. So what we have is NSX Intelligence, which actually came out with NSX 3.0, NSXT 3.0, where we can dynamically analyze the flows, the network connections, the user connectivity required for certain applications to work, and dynamically build the policies, firewall rules, permissions for our applications to work within VMware environments, and then deploy this across our NSXT environment. So no more guessing, no more, okay, did I forget this firewall rule? Did I set it up? How about those users? No, you basically rely on artificial intelligence. You rely on the big data analysis to actually determine which are the rules required for this app to work, implement it, monitor it, and actually go to sleep in the evening peacefully because you know that things are working the way that they should. Using the layer 2 to 7 application identity firewall, we can fully comprehend the identity of the users, identity of the apps, which protocols are being used, where certain application is running, which port it's using, and so forth. We can understand which encryption is being used, which TLS versions, etc. And using all of those mechanisms, again, we can set up full granular rules within NSXT to provide this filtering. Obviously, the attacks are getting more and more complex, so understanding the application behavior, understanding how certain apps should be behaving, how they shouldn't be, is basically part of what intrusion prevention, intrusion detection systems are doing. And again, using NSXT, we can attach those rules, attach those signatures to our VMs, to our workloads, and to actually reduce the complexity and reduce the CPU load. We can actually only utilize the rules that are required. So not use, let's say, all 13,000, 50,000 rules, whatever we have on NSXT, but no, only use the rules that are applicable to our environment. And as far as actual workload security goes, we really don't want to have another agent running inside our VMs. So in order for that, we can actually provide hypervisor layer security, again, which understand the context, provides intrinsic security within the environment itself, and secures the workload, again, based on the zero trust principles that we talked about. Okay, the last part that we talked about is secure connectivity. So using, again, secure connection establishment, using tools such as Workspace ONE Tunnel, which allows us to set up secure connections to our data center, to our workloads, to the clouds, etc. Again, based on the criteria that we set up, based on the context that we understand. So should the data go directly to the internet when using SaaS? Should it go to our data center, or should it be blocked? Again, it depends. It depends on the context. It depends on the criteria. It depends on the rules that we have created, that the whole environment should actually follow, and that get constantly checked. And if needed be, the connection can be dropped, and basically the context needs to be reestablished for the whole thing to actually work. This way, again, we can use the least privilege principle to understand the full persona policies when deciding what goes into the tunnel, to use the risk-based assessment, and to only allow access when we know that the risk is low enough. Otherwise, we require re-authentication, we require the device to gain posture visibility again, and so forth. And by using the VMware SCAC presence of POP, we can actually provide the full visibility and connectivity across any type of either remote access, remote branch, data center to database, and so forth, regardless of where the workloads are actually residing. So how do we set it up? What are some steps that actually need to be taken? So again, the whole goal is to provide user identity. to understand the device posture, to establish dynamic contextual access controls. Why? To protect our apps, to protect our data, and basically using the tools that we talked about, be it Workspace ONE, Carbon Black, NSXT, SD-WAN with secure access service edge, etc. We can actually use the intrinsic security built into those tools, and by following the basic steps which are needed to set up the zero trust environment, we can basically deploy the solution within our environment as well. Across the users, across the apps, define the usage and criticality, set up the zero trust policy, again, either manually or using the built-in tools, using AI and big data, and basically deploy this across our full environment within our VMware-based data center, edge, access, and user policies. Okay, thank you very much. I understand that if you have any questions, you can enter them in the question box, and I will review them once we're finished. And if you do have any other follow-up questions, please drop me an email at srancic@nil.com. And once again, for those of you who are working on the quiz codes, this is the secret keyword. Okay, thank you very much and have a nice day.